So we have the IR spectrum for our trimyristin, and the other thing we need to do is take a melting point. And we're going to use this Thomas-Hoover UniMelt capillary melting point apparatus. So the first thing to do is turn the power on, and if you look through the magnifying glass, you can see that what we've got is an oil bath. So we're going to turn the stirrer on, and you should see, I'm going to get my camera at the right angle, you should see that that oil begins to stir and we see some bubbles. And there's a little stirring blade down there. Right, you can see when I turn it on, that blade stirs our oil. So we want that stirring so we have a nice uniform temperature oil bath. The Thomas-Hoover UniMelt apparatus is a lot more expensive than the melt temp that you used in general chemistry, but it is more accurate because we get a nice uniform heat in that oil bath that you can't get with the aluminum block. So we got that stirring, and we have a magnifying lens here that will allow us to look at the bottom of our capillary tubes. You can see, I think, that there are 5 little slots in that metal plate at the bottom. That's where our capillary tube will sit. And then we've also got a periscope here that allows us to look at the thermometer. And if I get the camera at the right angle, you can see that we've got our thermometer here, and the mercury is at about 20 degrees right now. Hopefully you can see that. Right. Which means we haven't started heating it. We're going to heat it by turning this knob somewhere between 0 and 10, and probably, since we have a pretty low melting point for trimyristin, we'll only want to turn this up to about 1 or 2. What we're looking for is we'd like to have a rise of approximately 2 degrees C per minute at the melting point of the substance. So I got our vial of trimyristin, pure sample, and we're going to transfer some of that into a melting point capillary tube. I'm trying to do this one-handed with my left hand while I'm holding the camera with my right, so it'll be an interesting experience. And often the best thing is to transfer a little bit of substance to a glass, watch glass, because then it's easy to get it into the tube by just inserting it upside down. So I'm going to put the camera down for a second here. And I've now pulled just a little bit of solid into my watch glass. Maybe I'll need a little bit more. We're not using this trimyristin for anything else, so it's not like I have to be particularly sparing. So you want to make sure your powder is fairly finely divided, a nice uniform particle size, so you don't have chunks, and then kind of build it up into a little pile. What we want is 2 to 3 millimeters height of this powder in our capillary melting point tube. So we're just going to stick that on there with the open end, the open end of the melting point capillary, and we're going to stick that on there like that a couple of times until we have 2 to 3 millimeters of powder. Then we can either just tap the end of it to get it to go down to the bottom, or I think you remember from last year, you can drop your tube down a long glass rod and just let it kind of bounce on the desktop a couple of times, and that will get the compound into the bottom of the melting point capillary. Right. So we've got 2 to 3 millimeters of sample, nice and uniformly packed. We're then going to insert that into one of these holes. I'm going to stick it right into the middle hole there until that goes down and sits nicely. So now we can see that we've got our tube sitting nicely in the bottom there. You can see that clearly through the magnifying glass. We're going to be watching that to see when that begins to melt, and simultaneously watching the thermometer to see what the temperature is. So we're going to turn this up to a setting of about 1.6. And we're going to watch that temperature rise. This is obviously easier to see if you actually have your eye looking at it rather than my camera. And if you've already looked up the melting point of trimyristin, we know about when we should expect to see it melt. Fortunately, this is the closest I can get my camera to the lens or to the mirror. And the focal length is different than it would be for my eye. But I think you can see that the temperature is somewhere between 20 and 30 right now. And it's okay to set it, I can turn it up to like 2.5 to get it to start rising at a slightly faster rate. As long as I then turn it down when it gets close to the known melting point. And there's a nice little periscope that allows me to change what portion of the thermometer I'm looking at by turning the knob. Except that the camera is in the way of the knob. Makes it a bit of a challenge. So our temperature is gradually rising. We're up around 30-ish. So that's rising at a relatively nice slow rate. And we can confirm that substance is still not melted. Right, still a nice white solid in the bottom of that tube. We're maybe up around 35 now-ish. See that that's the 40 mark. So you can see the 40 and the 50. So our mercury has risen to right about 40. It's rising at a good slow rate. And I'm up about 2.4 on the dial. You don't want the temperature to be rising too fast because you want the whole sample to have time to melt before the thermometer rises above the melting point significantly. If it's rising too fast, you might see what looks like an expanded melting range just by virtue of the time lag between when the thermometer rises and when the sample actually melts. So this seems like a good, steady but slow rate of increase, where we're now at about 43. Probably could rise it a little faster, but let's just stick with this. Once again, we can see that our solid has not yet begun to melt. So we're going to watch that solid, and what we want is we want the range between when we first see a little bit of liquid and when the last trace of solid is visible. And we've got some air bubbles that are passing by from the stirrer. Hopefully get a good focus. There's a magnifying lens there that the camera is looking through. It's nice design on this instrument because the periscope and the magnifying glass that allows you to look at the sample are very close to each other. So you really don't have to move your eye very much. That doesn't make it any easier with the camera, but for your eye it would. So now if we look at our thermometer, see that we're up close to 50. So I can raise that periscope just a little bit. So you can see now the 50 and the 60 marks. And we're looking at the solid, and you can see that our solid has melted, right? And it melted somewhere in the range. Put the camera away so I can actually look at the myself. Looks like it melted somewhere around 53 to 55 degrees-ish. If you look at that, maybe I can get that to focus now. Right, you can see that that's now up at about 55. And our solid has melted completely.